All right, let's take a look at an example that deals with the double angle identities. So if you take a look at this one, tangent of theta equals 5/12. Theta is in quadrant 3, so we need to find the sine of 2 theta, and we need to find the cosine of 2 theta. Well, the sine of theta, 2 theta, is 2 sine theta times cosine of theta. And you got 3 choices for the cosine of 2 theta. It doesn't matter which one you use. I'm just going to use the first one, which is cosine squared minus sine squared. Well, we know the tangent of theta. In order to do either of these, we need to know the cosine and sine. So we have to create a right triangle. Since we're in quadrant 3, I'm going to draw this in quadrant 3. Opposite is 5, adjacent is 12, and they would both be negative since we're in quadrant 3. Well, you're going to use Pythagorean theorem. Negative 5 squared plus negative 12 squared is going to equal our hypotenuse, which we'll call c squared. Well, negative 5 squared is 25. Negative 12 squared is 144. You add those together, you get 169. And then when we are done, c is 13. Now, our hypotenuse is always positive. All right, so for sine of 2 theta, we get 2 times the sine of theta, which is going to be opposite over hypotenuse, which is negative 5 over 13. Cosine of theta is adjacent over hypotenuse, which is negative 12 over 13. Now, multiply those together. Don't forget negative 5 times, I'm going to keep the 2 out here for now. Negative 5 times negative 12 is 60. 13 times 13 is 169. And then 2 times 60 would be 120 over 169. So that would be the sine of 2 theta. Cosine of 2 theta, cosine squared minus, that should be a sine squared. And so cosine squared is negative 12 over 13, quantity squared, minus, and that's going to be negative 5 over 13, quantity squared. Well, that's going to be 144 over 169, minus, well, that minus doesn't get affected by the squared, but that one does, and that's going to become positive 25 over 169, and 144 minus 25 will be 119 over 169. So that'll be the cosine of 2 theta. All right, now using the same information, let me go to the next slide. Using the same information, tangent of theta equals 5 over 12. Theta's in quadrant 2. We're going to find the tangent of 2 theta. Well, that is 2 tangent of theta, if you look on your identity sheet, over 1 minus tangent squared. Well, the nice thing about this, we already know the tangent of theta. That's 5 over 12. So this becomes 2 times 5 over 12 over 1 minus 5/12 squared. Well, 2 times 5 over 12 is 10 over 12. And we get 1 minus 25 over 144. Well, 10 over 12 is 5/6. You want to make the 144 over 144 minus 25, which will give you 119. Whoops. 119 over 144. So now I got 5/6 times 144 over 119. Well, 6, whoops, I want red. 6 will go into 144 24 times. So now 5 times 24 is 120. 1 times 119 is 119. So you'll get 120 over 119. Now you may have noticed, a few of you may have noticed, well, tangent of 2 theta can always be written as the sine of the angle over the cosine of the angle. So we got sine of 2 theta over cosine 2 theta. Well, we actually already know those from the previous slide. Sine of 2 theta is 120 over 169. Cosine is 119 over 169. So I could have used those right away. Doesn't matter. So I could have made that 120 over 169 divided by 119 over 169. Well, if I multiply my fractions, then 169's cancel, and I'm going to be left with 120 over, hold on here, 120 over 119. Same thing. Doesn't really matter which way you do it. If you notice, if you have the sine and cosine, you can move immediately to there, or you can use a tangent formula. All right, another type of problem you'll see is will look like this: cosine squared of 22.5 minus sine squared of 22.5. If you look at your identity sheet, that'll look like cosine squared alpha minus sine squared alpha. And if you have that, that means we can rewrite that as the cosine of 2 times the angle. Well, so in our case, the angle is 22.5. So you can write that as cosine of 2 times 22.5, which just becomes cosine of 45 degrees. And the cosine of 45 degrees is square root of 2 over 2. And that's all you got to do. So that'll be your final answer. All right, we're just going to kind of start slow with this section. And those are the 2 kind of main problems we deal with. We went over the proofs of how to generate the identities. But here's what I want you to do for the rest of the period. I want you to work on page 652, 9, 11, and 13, 15 through 18, all. Okay. I hope everyone has a great weekend, and I will see you on Monday.